Welcome to Lesson 8, where Nginx stops just serving files and starts standing in front of your applications. From here on, every request flows through Nginx to a backend, Node, Django, Rails, anything that speaks HTTP. The whole topic comes down to 4 pillars: proxy pass to forward the request, X-forwarded headers so the backend knows who's actually calling, buffering to handle mismatched client speeds, and timeouts to decide when to give up. Master these 4, and you've got a production-ready front door for any stack. Here's the map for the lesson. Idea 1. Proxy pass. A single directive that forwards the request to your backend, with one subtle trailing / rule that decides whether the location prefix gets stripped. Idea 2. The X-forwarded headers, because without them, your backend thinks every request came from localhost. Idea 3. Buffering, which lets Nginx absorb slow clients so your app doesn't sit there waiting. And Idea 4. Timeouts, connect, send, and read, deciding when Nginx stops waiting and returns a 502 or 504. 4 ideas, and you're done. Before we touch any config, picture the request as it actually moves. The client sends get API hot users to shop.com. Nginx matches the API's location, strips the prefix because of the trailing / on proxy pass, and forwards get users to the backend. Along the way, it preserves the original host and adds X-forwarded for, so the backend still knows the real client IP, instead of just seeing Nginx on localhost. Every proxy bug we'll debug later is a deviation from this picture. That trailing / I just mentioned? It's the single most confused detail in Nginx proxy, so let's nail it down. With a trailing / on proxy pass, the location prefix gets stripped before forwarding, so .api.users reaches the backend as .users. Without it, the full URI passes through untouched, and the backend sees API.users. Pick based on how your backend routes are written. If it expects .users, use the /. If it already expects API.users, leave it off. And when in doubt, point proxy outpass at a Python http.server on 3000. Every line it logs is the exact path Nginx forwarded. Ground truth, no guessing. Now, with proxy pass sorted, we hit the second pillar, headers. By default, your backend sees every request coming from 127.0.0.0.1 on some random port. It has no idea who the real client is, what host name they typed, or whether they came in over HTTPS. These 4 lines fix that. Host preserves the original domain, X real IP carries the direct client address, X forwarded for appends to the existing chain so multi-proxy hops stay intact, and X forwarded proto tells the backend which scheme to use when it builds redirect URLs. Drop this into a snippet under etc. Nginx snippets and include it in every proxy location. Write it once, never think about it again. Pillars 3 and 4 work together. Buffering, which is on by default, lets Nginx absorb the full response from your backend and dribble it out to slow clients, so your Python worker isn't held hostage by someone on a bad mobile connection. The one time you flip it off is for streaming, SSE, WebSockets, long polling, anywhere bytes need to flow through immediately. Then the 3 timeouts map cleanly to the 3 things that break: connect, send, and read, and the payoff is diagnostic. A 502 means you never reached the backend. A 504 means you reached it, but it was too slow. The status code tells you exactly where to look. So here's what all 4 pillars look like assembled into one VOST. Notice the headers and timeouts are set once at the server scope, so every location inherits them. No duplication. Then 2 locations are API, forwards cleanly to Node on 3000, and events does the same but flips buffering off for SSE. That's it. That's a production-grade proxy. Change the backend address and you can ship this today. Now that you've seen the config, let's step back and ask why we even do this. 3 reasons, and they all compound. First, backends are slow at I/O. Your Python or Node worker is precious, and Nginx buffers responses, so a slow client on hotel Wi-Fi doesn't pin a worker for 30 seconds. Second, one public URL can fan out to many backends behind the scenes, APIs, WebSockets, static assets, and you can rewire that topology without the client ever knowing. And third, you get to add rate limiting, gzip, caching, allow lists, all in config with zero application code. App logic stays in the app. Infra logic lives in Nginx. So here's the cheat sheet. 7 directives that cover almost every proxy decision you'll make. Proxy pass is non-negotiable. Proxy set header is where you fix host and forward the real client IP. Proxy buffering you turn off the moment you're dealing with SSE or WebSockets. The 2 timeouts handle your network reality. Drop connect, timeout on a fast LAN, raise red timeout for slow batch endpoints. Proxy, HTTP, version 1.1 unlocks keep alive and WebSocket upgrades, and proxy redirect you'll almost never touch. Screenshot this one. Time to put hands on keys. 3 drills, all on your own VM, all using a Python HTTP server as the back end, so you can watch exactly what Nginx forwards. First, you'll set up a basic proxy pass and prove the trailing / rule from slide 4. Same config, 1 character difference, completely different path downstream. Second, you'll wire in the 4x forwarded headers and watch real client information reach the backend instead of localhost. Third, you'll deliberately break things. Kill the backend for a 502, stall it for a 504, and learn to read error.log like a debugger. 50 minutes and proxying stops being theory. Before we wrap, a field guide to the 5 mistakes that will bite you. Wrong trailing / on proxy.pass. Your prefix either doubles or vanishes. Missing host header. The backend sees localhost and writes broken redirects into every email. Forgotten X forwarded proto. HTTPS turns into an infinite redirect loop. Proxy read timeout left at 60 seconds. Legitimate slow endpoints return 504. And WebSocket without proxy, HTTP version 1.1 plus the upgrade and connection headers. The handshake fails silently. Each one loads a page that looks fine and breaks something subtle. Memorize the symptoms. The fixes are right there in the green column. And that's lesson 8. You can now put Nginx in front of any backend with confidence. Proxy, pass is muscle memory. The X-forwarded headers carry the truth upstream. Buffering behavior holds no surprises. And when a 502 or 504 shows up, you know where to look. Next up, lesson 9, load balancing. We'll take a single backend and turn it into an upstream pool, pick the right algorithm, and add health checks so dead nodes stop taking traffic. See you there.